In an effort to prevent expensive shutdowns and unplanned maintenance downtimes, facilities across the globe today rely on a variety of preventive maintenance methods. Many studies indicate that temperature rise, otherwise known as hotspots, is a major cause for these failures. These abnormalities are often caused by loose connections as a result of vibrations, unbalanced loads, overloaded conditions, and a wide range of other issues often found in conductive environments. Most industries use either routine physical inspections or thermography programs to detect temperature abnormalities. Physical inspections require the user to open the electrical enclosure, barriers, and other insulating materials in order to inspect the connections. Since most facilities prohibit their personnel from this type of high-risk access, the data obtained is often inaccurate or unobtainable. Additional risk of failure exists when the equipment is not put back in the original condition after inspections. To overcome these shortfalls and to measure the temperature of the live conductors, some facilities use infrared cameras and windows. With this method, an IR camera is directed at a live conductor either directly or through an IR window to measure the rise in temperature. In some cases, the IR camera or the window visibility is restricted by the connection location and field of view of the IR window. To help you address these concerns effectively, we'd like to introduce our new GraceSense Hotspot Monitor, or HSM, a continuous real-time temperature monitoring device intended for locations that are difficult and hazardous to access. This device not only measures the temperature at any given point in time, but also proactively monitors and enables the user to predict the failure before a potential shutdown. The HSM utilizes patented fiber optic technology, providing constant temperature data available in 9 or 18 independent sources. The fiber probes can be mounted onto electrical bus bars, bus ducts, transformers, or any other source of heat. The Hotspot Monitor provides a unique combination of patented fiber technology and advanced algorithms that convert the change in light intensity to temperature. The patented fiber probes securely connect to a ring-style connector that conveniently mounts to the source of heat, while the other end connects to the HSM module. Sources of heat may include inaccessible equipment and blind spots to IR scanning. The most obvious benefits of the HSM over IR thermography come from the continuous real-time monitoring feature. In addition, the successfully proven measurement accuracy of the probes is not subject to calibration errors, as can be the case with IR scans. The Hotspot Monitor comes with 16 megabytes of built-in memory for data storage. By connecting the GraceSense HSM module via Modbus TCP/IP or Ethernet IP and accessing the web utility tool, users can configure the temperature thresholds, time intervals, and relay outputs. This tool further enables access to the real-time data logs and downloads the stored data for analysis and trending, connecting directly to the device or safely through closed doors using a GracePort Ethernet connector interface. GraceSense Hotspot Monitor is a reliable and affordable solution for use in environments with low, medium, or high voltage systems. The HSM is available in 2 versions, either a 9-point module with a built-in LCD display or an 18-point module. The unit comes fully kitted with fiber probes, ring-style connectors, and an installation kit. Optional accessories include a Modbus current sensor, high-temperature probes, ambient measurement attachment, custom connectors, and fiber lengths of various sizes. Continuous real-time monitoring, our answer to your most demanding and critical applications where guesswork and downtime is not an option. To learn more about our Hotspot Monitor, visit gracesense.com or call 800-280-9517. Find faults before they find you.
So the topic for today is NFPA 70E, safety-related maintenance requirements for electrical equipment. Good morning, my name is Bhanu Srilla. As most of you know, I'm the Director of Technical Product Marketing here at Grace Engineered Products. I've been with Grace for about 5 years now, and I'm not going to read through all my credentials right now. Just if you want to know more about me, just Google my name or find me on my LinkedIn page. So the topic outlined for today is so general maintenance requirements of electrical equipment as it applies to NFPA 70E, and the basic guidelines for substation equipment, MCCs, panel boards, circuit breakers, disconnect switches, and also the PPE. So this is more so in alignment with what the chapter 2, which is article 200, talks about in NFPA 70E, and also learn how often the scheduled maintenance has to be performed on those equipment as well. So we're going to touch base on two things here. One is NFPA 70E standards. One is the ANSI META 2019 edition, which is the recommended practice for electrical equipment maintenance. And also we're going to touch slightly on NFPA 70B as well, okay? So let's take a quick fact check on the maintenance. So what is the basic reason when we ask most of the facilities personnel about why do they perform maintenance tasks, right? The first thing that comes into mind is equipment shutdown. So people don't perform any kind of a maintenance task unless otherwise there is something that's broken, right? So this is more like a reactive approach what we do. And then the second step is whenever there is a physical signs of imminent failure, like if you see a hot spot or if there is a arcing or a flashover inside the cabinet that you visually can see it, or you can see any kind of a temperature rise on the equipment, then you send someone to go and perform the task, right? And last two things are like pretty common. I do this maintenance task because my boss asked me to do this, or I have the procedures or policies in place which would demand me to do the task, right? And lastly, I just do it for checkbox for the records. So most people don't really know why they're doing the maintenance, because maintenance is also required by Occupational Safety and Health Administration's Code of Federal Regulations, which most people think that, hey, I need to just put a checkbox on those maintenance sheets or the records to make sure that I'm complying to those requirements. That's another reason why the people do it. Okay, so in reality, why do you need to be really doing the maintenance, right? The first thing is support the facility operations and production. You need to make sure the equipment is running to its optimal level and you are producing the desired outcome of your equipment and the production capabilities. And the second one is ensure the equipment performance to design spec. So when I meant the design spec, I'm talking about the equipment not performing at a 40% efficiency or a 50% efficiency. You're shooting for 90 or 95% efficiencies to what the equipment has been designed to. And then the last next bullets are avoid unplanned downtime. So you don't want this equipment to just go down on its own clock. So you just want to make sure that the system shuts down based on the planned outage, right? And then they extend the equipment longevity. Most of the times, the equipment is designed for 20 to 30 years in normal situations, and in some cases, it's designed also for 40 to 50 years. I mean, we come across most facilities where they have this equipment for 40 to 50 years. One thing is they are maintaining the equipment to ensure they're getting the desired longevity of the equipment as well. And the next bullet is the low total cost of ownership. It is not just the maintenance is a function of on a regular basis you go and perform a task. It's also the design feature as well, right? So when you look at the total cost of ownership, you're taking into consideration the design standards, the installation cost, and also the cost of maintenance, which gives you the complete aggregate of the total cost of ownership. And the last two bullets are very important because one on the previous slide we touched, which is complying with the regulatory needs, because as I mentioned you, Occupational Safety and Health Administration has a clear directive on what it means when it comes to the maintenance of the equipment and also the hazards as they relate because of the maintenance of the equipment that leads to any kind of the hazards to the workers or the employees. And last is keep personal safety. So you need to make sure that you're doing all this maintenance tasks to ensure that the people who are working around the equipment, I'm talking about two levels of employees here. One is the person who is doing the maintenance tasks, and the second one is the one who is doing the operation, right? Like a machine operator is also considered as a person who is involved with that operation as well, okay? So when it comes to the electrical work environment, these are the three standards as I'm showing it on the screen: installation, maintenance, and safe work practices come into play, right? So you can't accomplish a safe work practices without the use of installation and maintenance. These three things are tightly interrelated, meaning you need to make sure the equipment is designed and installed per the required codes and regulations, right? And then you also need to maintain the equipment to ensure it's safe for the people to work around those devices. And the last one is safe work practices, which is more so in terms of the personal safety. So if you look at NFPA 70E alone, NFPA 70E calls out in specific areas. There is a call out to NFPA 70B, which is a maintenance standard for recommended practice for electrical equipment maintenance, and also the installation codes, which is NFPA 70 or NEC. Okay. So what is the role of maintenance condition? Condition of maintenance play a major role when it comes to safety, because as I mentioned in the previous slide, it includes two types of workers. One is the maintenance worker, who is performing the tasks or the maintenance or repair functions around the equipment, and then the next one is the operator. So improperly maintained equipment can put both the maintenance worker and operator at risk. When I say the operator and maintenance worker, so I'm talking about the maintenance worker who is doing electrical tasks or mechanical tasks, so like lockout, tagout, or the person who is doing the production activities on that specific equipment. And last but not least, there is also a significant role of the owner or the operator, because when I talk about the maintenance in terms of occupational safety and health administration, which we'll see in the next slides, we talk about the responsibility of the employer and the employee as well. Let's go to the next slide. So this slide, I'm outlining what chapter 2 talks about, specifically on the safety-related maintenance requirements and who is responsible for the specific areas, right? So when it comes to the equipment, it's not only the employee who is working around the equipment is responsible, but ultimately the prime responsible person is the equipment owner, right? So maintenance directly associates with the employee safety while doing the specific maintenance methods. It is the employer responsibility to choose from the various standards or the methods that they can adapt to, right? So if you look at some of those areas when bringing in the third-party contractors to do any type of the maintenance task, still you do have this employer or the owner of the facility or the owner's designated representative's responsibility within that equation. So make sure that it's not just the employee who has to be careful while performing the tasks. It's more so the employer or the owner has to provide those tools and resources for the persons before they perform the task. Okay. So if you look at the maintenance language from NFPA 70E 2018 edition, there's one definition that's been added. It's called maintenance condition of. This is the state of electrical equipment considering the manufacturer's instructions, manufacturer's recommendations, and applicable industry codes and standards and recommended practices. So if one just dissect into this specific language, what it's saying is you need to follow the manufacturer guidelines or instructions when you're performing this maintenance tasks, right? You need to go back to the instruction manuals or installation guidelines provided by those manufacturers on their scheduled maintenance activities for that specific equipment, right? And if you don't have those, then you can go and follow the consensus standards like NFPA 70B or ANSI meter standards, right? And also industry guidelines per se. And then if you look at the next bullet, which is Article 110.1, conditions of maintenance has been called out, even that specific section within Article 110.1. And then when you look at the 130.5, which is the estimate likelihood and severity of this risk analysis of this electrical hazards, you need to also take into consideration the condition of the maintenance of that equipment itself. Not only the worker qualifications and installation guidelines, you need to take into consideration what those requirements or the maintenance condition of that specific piece of equipment too, okay? So I'm going to talk in a few slides about the Occupational Safety and Health Administration's Code of Federal Regulations. What I'm showing here is 1910-303. Electric equipment must be free from recognized hazards that are likely to cause death or serious physical harm to employees. In simplistic terms, you need to make sure that equipment is well maintained, it's not posing any kind of imminent danger or hazard to the people who are working on that equipment. That's how OSHA connects the dots when it comes to the maintenance of this equipment, okay? And then if you look at the 1910-334, if there is evidence of damage that might expose an employee to injury, the defective or damaged item shall be removed. So if an employee, the worker is performing a task, or if he's doing an inspection around that equipment, right? And if he comes across a red hot spot or a temperature rise or a small arcing inside this person has to make sure that he informs the employer and they take the corrective action so that they take this defective equipment out of service and then they perform the maintenance tasks to take care of that. So then 303, Internal parts of electrical equipment, including the bus bars, wiring terminals, insulators, and other surfaces, may not be damaged or contaminated. So this is directly connecting to any type of loose connections within the bus bars or the circuit breakers or the bus ducts, whichever the electrical current carrying conductors. They need to make sure that these parts are maintained such that there is no contamination or damage to any of those. The next one is 1910-303. No damaged parts that may be adversely affect the safe operation, mechanical strength of the equipment, right? So you can't have equipment running if there is structural damage to the mechanical strength or integrity of the equipment itself, okay? So this is a table 135C taken out from NFPA 70E, which considers equipment condition to be normal if all of the circumstances apply. So if you look at the step 1 through 6, this is primarily talking about the equipment is properly installed in accordance to the manufacturer recommendations, which goes to NFPA 70, right? NEC code. The equipment is properly maintained in accordance with the manufacturer guidelines and applicable industry codes, which is again what we talked about on the conditions of maintenance of, right? And then the third bullet is the equipment used in accordance. So you need to make sure the equipment is not used than what it is designed for. A good example would be you can't use a low voltage system on a high voltage, or you can't use a low voltage Cat 3 duty test instrument on a Cat 4 application. This is what they're mentioning as used in accordance with the manufacturer guidelines. So there's this direct connection between how the equipment is installed and also how it's used if you take the application context, and also if you put what the manufacturer has designed this equipment to, okay? So equipment doors are closed and secured. So you can't say this system is in a normal operation, keeping all the doors open, right? I mean, if you want to talk about an example of a thermography, it is allowed because it's a diagnostic work and somebody is doing this measurements for doing temperature monitoring, doing opening the door, and these people are qualified persons as well for NFPA 70E. And equipment covers are in place and secured, and there is no evidence of impending failure such as arcing, overheating, loose or bound equipment parts, visible damage or deterioration. So this is basically when you go and look around this equipment physically, just a walk-in inspection, you need to make sure that there is no visible or imminent failures that's there around this equipment, okay? So this is again from article 130.2, which is a normal operation. The same thing, basically, you need to follow the 6 steps before you think or before the equipment is construed as put in a normal operation, okay? So chapter 2 talks about the safety related maintenance requirements when it comes to electrical equipment. So this is part of NFPA 70E, which talks about the general maintenance requirements, the requirements for the overcurrent protective devices or OCPDs, identification of the components, identification of circuits and conductors. So I'm going to make a quick disclaimer because this topic is so vast. I kind of picked and chose what those important factors when it comes to on a day in, day out basis, when it looks at the maintenance and how to maintain this. So I skipped a few areas like the batteries, I skipped the areas on the hazardous areas, and also a few other elements within that as well, okay? So Article 205 talks about the single line diagrams. The first thing is you need to make sure the electrical system single lines are kept intact and they are maintained so that the person who is performing the task is capable of reading those and interpreting those SLDs. Because if SLD is not updated, if you make any kind of modifications to the trip settings or to the location of the breakers, that could change the entire thing, right? So then, though this person is qualified, he is not aware of those imminent dangers or the risk that's exposed to, or there could be a change in the trip settings that could put a different arc flash category on the same piece of equipment, which without knowing these changes, a user or a worker who is working around that equipment cannot foresee those criteria, okay? So Article 205.3 talks about general maintenance requirements. So it clearly calls, it shall be maintained in accordance with manufacturer instructions or industry standards. As I previously mentioned, if you want to tie in that OSHA CFRs to this, it has to be maintained for manufacturer instructions or industry standards. So industry standards, you can use it only if there is no direct connection to that equipment from the manufacturer provided guidelines, okay? And also it helps reduce the risk associated with the failure And last bullet, equipment owner or the owner's designated representative shall be responsible for maintenance and documentation. When I say shall, it is like mandatory language. It is like a legal language you must have to adhere to. Okay. So Article 205.4, overcurrent protective devices. OCPD shall be maintained in accordance with the manufacturer instructions or industry standards, and maintenance and inspection tests shall be documented as well. Not only you perform these things on a regular basis, but the maintenance guidelines is required, but also you need to make sure that these things are documented and test reports are kept in place as well. Because if you don't have the documents in place, then it means that did not happen. Okay, so just make sure the importance of documentation is very critical, that while doing all these things, you need to make sure that you need to maintain the documentation as it relates to that. Okay, so additional points, you need to make sure the breaker is maintained properly, exercising the breakers on a regular basis for the manufacturer guidelines again, right? And the use of remote mechanisms, because there are a lot of this remote mechanisms that's available for breaker rack in, rack out, so you don't need to have your personnel go and physically interact with that within that restricted approach or limited approach boundaries. You can just have them do this at a far remote areas that will minimize that exposure to that hazard. And repairs and modifications are performed using authorized OEM guidelines. So this one is really important, because whenever you make any kind of service work over your MCCB or your breaker, you need to make sure that these things follow the manufacturer guidelines. And if you make any kind of modifications to the gear, a good example would be you just put IR windows, for instance, right? So you need to make sure that IR windows align with the manufacturer guidelines, and the OEM is approved of those things, right? And acceptance testing, because if you make any kind of physical change to the system, you need to probably have an AHJ inspection after the modifications are made to make sure that the system is restored to its normal original working order. Okay. So Article 245 talks about the portable electric tools and equipment. So you need to make sure these 5 things are important, because portable electric tools are one of the things which industries use on a regular basis of more frequently, right? So there are no breaks. You need to make sure you check for the cord and plug equipment. There are no missing cover plates. Terminations are no stray strands or loose terminals. There is no missing or loose or altered damaged blades. And also make sure the polarity is correct, right? So make sure whenever you use this cord and plug disconnects or portable tools, you just check this cords, insulation, the strands and everything, they are intact before you use them, okay? So Article 250 is a huge list, because this is one of the major foundations of the electrical safety, because PPE and the protective equipment and personal safety comes very, very critical. I'm highlighting this 14 things here: grounding equipment, hard stakes, because these are all used. If you take the electrical safety in the context, these are the things that the electrical qualified workers will use on a day in, day out basis. So they bring a predominant focus on this specific area, because there is a huge need for people to make sure that things that will protect an employee in case of a hazard are properly maintained and also tested on a regular basis to make sure that there is no deficiencies in that effect. Okay. So inspection testing. So if you take this 14 items what I showed here, so you need to have the visual inspection, inspect for damage or defect before initial use. So whenever you put this first time in service, you need to make sure there is no damage, so you visually inspect that. And the intervals thereafter, you need to make sure the service conditions are maintained. So the max, they say, is basically 1 year. No case shall exceed 1 year unless specified by code or a local authority or a federal or a state requirement. So you can alter this unless otherwise there is a change defined by these regulatory bodies. Okay. So testing, installation of the protective equipment and protective tools used as a primary protection from shot has to be tested. No case that shall exceed 3 years. Once in 3 years, you have to make sure that your things are tested. And Article 250.3 talks about the safety grounding equipment. So you need to make sure do the visual and also testing. So visual includes the cutting protective sheathing, damage to conductors. You need to make sure the clamps and the strain relief of those devices for tightness, and the inspection shall be made thereafter as condition required. So basically, if you perform a task, right, and then you perform a task after like 2 days or 2 months, I mean, there is nothing wrong in going and re-inspecting or looking at it for a visual checks to make sure that nothing has broken, right? So every time you put it back in service, it's always good to just have that visual check to make sure there is no signs of damage. And testing has to be done prior to the return to the service equipment that is modified or repaired, right? So whenever, as I mentioned before, whenever you perform any kind of a maintenance or repairs to that, you need to make sure that that equipment is tested in accordance with the manufacturer guidelines or the industry standards before you put it back in the service condition. So grounding and testing devices is another area which shall be stored in the clean and dry area, and also shall be inspected and tested before each and every use. So this is the one thing, it's not like once in a year or once in 3 years. You have to test this and inspect this before each and every use. And if you want to look at what those guidelines are, it's defined in IEEE C3726, which is the standard for 4.76 kV to 38 kV ground and test devices used in enclosures. Okay. So the next one is Article 250.4 test instrument. This is one of the favorite areas where Grace plays significantly, using the portable test instruments for absence of voltage or presence of voltage testing. This applies to portable test instruments in this area, specifically the call about if you're using this device for verifying a presence or absence of the voltage that has to be maintained to assure the functional integrity. So, I mean, most of you know that Article 120.5 requires a live test, right? So you need to make sure the maintenance program include the functional verification. You need to make sure that portable test instrument is calibrated and verified for the accuracy, and also assure the functional integrity is maintained when those tests are being performed. So make sure that your test instruments are maintained and calibrated to the effect. Okay? The next one is the fundamentals of electrical equipment maintenance. So you need to look at the design for maintainability. So whenever you look at this, is again taken from NFPA 70E, which talks about why do you require the electrical equipment maintenance program, right? So before even the maintenance comes into play, there's a design aspect, right? So when the companies put together the design specifications, they need to look for the design for maintainability criteria that's clearly defined, right? So a simple example is you don't want that equipment to take about 15 hours to change a small fuse if it requires just only like 10 minutes, right? So just make sure that things that requires the maintainability are kept in a place where it's easy to access whenever there is a maintenance task performed. So what I'm trying to say is, during the designing functions of any type of electrical equipment, you need to consider the design for maintainability feature that will give the safe and easy access for the qualified persons to perform those tasks for the manufacturer guidelines. I think end users can also ask for it in some cases, and most of the manufacturer required design specifications provide that as well. So coordinate the maintenance activities with planned production outages, because there should be interaction, what I call, between the manufacturing groups and also the production groups to make sure those two departments are working in sync. The reason is you don't want to schedule a maintenance activity on this when the people are running this thing at a 90% production, when the production or the management is requiring the high output, right? So you need to make sure that the maintenance operations or these things are performed in sync with the production outages, so you can align these activities. So there should be a dialogue between the production and the maintenance teams. So selecting equipment considering future growth. So these are kind of all the things that I refer to as a design criteria. Before you're designing an equipment for this facility, right? So you foresee in the next 5 years or 6 years, what is this projected load is going to change, and you can design the equipment so you don't need to go and change the equipment in that given 3 years or 2 years time. So always make sure that you have a future growth capabilities built into your equipment. For example, you require 3000 amps, for example, complete full load, right? So you probably plan for a 5000 or 4500, depends on, you foresee that there's going to be an increase to that load so that you don't change that main breakers on a short-term basis. And cost of maintenance replacement spares necessary for this fundamental maintenance practices has to be also taken into consideration, because you need to understand the impact of various types of equipments, and you want to standardize those to make sure that you have the same type of breaker, you have 2 additional in your spares. So if there is something that goes wrong, you have this extra spare that you can just rack in and you can bring the production to normal, right? And also you need to make sure that your replacement spares like your fuses or any other regular consumables are kept in place as well, okay? So benefits of electrical preventive maintenance, effective scheduling of activities. So what I call the effective scheduling here is basically you perform this maintenance functions or plan this maintenance activities around your production outages, and also you have that scheduling that's been done based on the prioritization of the equipment. So limiting outage impact on the operation, because if you know what is the maintenance condition of that equipment, you can basically predict when this equipment is going to fail or what is the next thing that we need to do. So in that way, you can limit the outage impact on operations. So you can give more uptime to your manufacturing operations. And next thing is coordinating the spare parts. So if you have a planned schedule in place, you can basically forecast what is the consumables or the replacement spares that's required for this specific activity, and you can bring them ahead of time instead of just having the machine shut down on a chaotic basis where you need to expedite the parts or expedite the labor, and also spend too much money on overtime costs and people going through taking some shortcuts as well, right? So make sure you have a proper tools availability while performing this task. Make sure that they have the right tools and the protective equipment for them to safely perform this task. And last but not least, make sure the person who is doing this task is a qualified worker, because the qualified workers are not available on a regular basis. They're not freely available in an industrial setting, right? So you need to make sure that the qualified persons are available to perform the task so that you're not having somebody else who is not qualified performing the same task. That would create additional hazard, okay? So here, a quick comparison between maintenance versus risk exposure. So when I talked about the maintenance aspects, we talk about the corrective, which is more like a run to failure, and which is next is the preventive, and the third is the condition based. Okay, run to failure, you don't do anything, you go and attend to this task when something breaks down, right? So something breaks down, you're going to have your qualified persons or whoever is available on your shift to just go and attend to the task and fix that. So I call it high risk because when people are under pressure to perform these tasks, right, they are taking shortcuts, they're not donning the PPE, and they're trying, their main motive is to just get it done, fix, and turn it back because they have humongous pressure. When you take the next step, which is a preventive or a schedule based, it is limited risk, right? Now you're just doing this maintenance based on your clock, right? It's based on availability of your personnel at your maintenance outage time, which is planned, right? So your exposure to hazard is limited. The risk is limited in this case because in high risk places or high risk actions in a corrective approach, you're taking shortcuts, you're not donning the PPE, you're trying to, on a firefighting mode, get things done. Whereas in the preventive, you know what these things has to be coordinated and organized, so the risk is limited in this way, right? And when you go to the condition based, which is more like extremely low risk, because in this case, you're not just planning these activities or performing this based on the scheduled maintenance guidelines or the activities as what it's defined. You are more so monitoring these conditions of the equipment on a more proactive basis using some kind of a sensors or some kind of monitoring systems, remote monitoring or capability tools that gives you a trend over time where you are monitoring the condition of that equipment and then applying the people when there is a need. So that brings your risk extremely down. I thought this is very important because as you look at, the more you go on a run to failure approach, you are exposing your workers to a higher risk compared to the condition based one, you are extremely low risk, right? So chapter B of, chapter 4 of 70B talks about deterioration, failure is inevitable. And if you have an EPM in place, right, electrical preventive maintenance program in place, you can delay those failures. So more so like it's a planned one, so you can delay this and you can ensure that people are working on this and the equipment uptime is given to your production capabilities. And the ROI is pretty big because when you try to do this maintenance task in terms of preventive to corrective, right? Corrective is about 5 times what the industry says is about 5 times in what it would otherwise cost for preventive maintenance, right? If, for example, you were spending $100,000 for bringing the equipment down, because you know there is a preventive maintenance that has to be completed, right? And then if you have to do the same thing, if the equipment shuts down, you are not only taking into consideration the cost associated with that specific spares or the time the work is performed and such, you're also adding to that in multiple ways. You're adding your supply chain, your customer value, right? So you can't get your goods to your customers on time. And it could also affect the entire supply chain. And we spoke to some of these automotive companies, and their downtime is like $20 to $1,000 a minute or so. And the same thing with data centers and stuff. So where they have this high redundant systems in place to mitigate those type of risks. Okay. So having redundant system doesn't mean you don't need to do maintenance. You need to do maintenance basically to ensure that redundant systems also function if there is a need. Okay. So breaker maintenance. So this is one of the major things that we come across, right? So low voltage power circuit breaker should be inspected on an annual basis, and also the test has to be simulated under overload and fault conditions once in every 3 to 5 years. Because the main reason here is not only you just have the breaker that's sitting there, it's going to function when there is a fault occurs, right? You need to make sure the system is going to perform to its designed function, like a tripping in terms of the breaker. The breaker has to trip in case of fault or in case of overload conditions. So how do you know it? You know it only if you test it. So the testing has to be done with reference to the manufacturing guidelines and also the industry standards. The next one is the investment in a few spare breakers, right? So as I mentioned before, you can have the similar identical piece of equipment in store, like 2 or 3, right? So that will help you basically, if something goes wrong, you have something in spare, you can just bring it in and put it back in service. The in-service breakers could then be exchanged with spares at opportune time. I mean, these are things where you can cut down significantly the downtime, because the more you cut down the downtime, it's going to help you to keep your operational output or the productivity measures at a high rate. Okay. So MCCBs, this one point I came across, this 130.6 requires determine the cause of breaker trip. So this is the one thing which most of us we do even in your residential breakers as well, right? So the first tendency is basically if something trips, we go and reset without knowing why it tripped in first place. So 70E specifically requires, Article 130.6 requires to determine the cause of the breaker trip before you go and reset it. So there could be a fault the other side. That's why the breaker tripped. You need to make sure you're not going to close on the fault. Okay. So also non-qualified persons are not allowed to reset the breaker. So I'm not sure how many people really follow this, right? It's an industrial setting, because an operator can go and look at the breaker trip, and then because of the production pressures, he would just go, it's just a switch, I can go and turn it on. And that could be a huge risk for this person, right? Must be replaced if frequent trips are documented. So if you're seeing a regular pattern of this breaker stripping or a nuisance stripping, it could be because of fault or not. You need to make sure that you take this breaker down and verify its functionality is checked before you put it back, or replace it if it's doing that on a regular basis. So this is a slide where I'm showing the pictures, because all these previous slides were pretty text heavy, so I want to show you some pictures here. So this is loose connections, where you look at some of the terminals got burnt out. The one on the right here, on the top here, is a bus duct flashover. This is one of the Facebook incidents I showed 3 years ago. And here is one of this, the odd contacts here. The point I'm trying to make here is the loose connections are one of the major things when it comes to electrical flashovers or the arc faults and such, right? So the degradation over time will lead to this kind of scenarios, which could be completely preventable. So if you look at the threaded connections on chapter 811 from NFPA 70B, it's important for threaded connections to be properly tightened. So tightening the connections brings 2 questions: is, are you tightening this to the proper torque or not? Are you just over torquing or under torquing, right? So the verifying the torque values of initial installation is not reliable. So some people say that, hey, I'm just bringing in the equipment from the manufacturer side who shipped it to me. Do I need to retorque this? Yes, absolutely yes, because there's a high possibility, because of the storage requirements or because of the transit requirements or the shipping, these contacts would have gotten loosened, right? You need to make sure that you go and recheck the torque values. It is normal for the metal relaxation also to occur after installation time. So the regular torque tightening techniques must be used, and they need to be used in accordance with the instructions provided in 70B or ANSI meter, which I have it in the last slides, where you can go and check for these values, reference values. So here is the temperature monitoring systems. I'm kind of showing multiple things here. So one to the left is a thermography using open door thermography, or a closed door thermography using a window or an IR camera. This is explained in a very great depth in chapter 11.17 in NFPA 70B. You need to make sure that you follow this temperature monitoring, because on the previous slides I showed these loose connections. These loose connections can be monitored using these non-contact type devices, where you can monitor the temperature using thermography as one of the tools. But you need to also understand the pros and cons of every technology, right? So you need to understand, whenever you do a thermography program, you're not just shooting an IR camera like at the airports, what people are doing right now to monitor the temperature. So you need to make sure the thermography scanners are certified, right? They know what they're looking at. They know how to interpret the values. They know what temperatures or what scans they're doing. And then they need to document these values as well thoroughly. So it's not that, unless otherwise you have a qualified thermographer in your team, don't just take a camera and just look at things. It doesn't make any sense, okay? And then what I'm showing to the right here are some of those remote monitoring devices. The one that's yellow here, I'm just pointing on the screen, it's basically the hotspot monitor, which is our gray zone product, temperature monitoring device. I mean, the advantage of this device is basically you connect this using a non-contact fiber optic technology, so you can monitor the temperature measurements remotely. So in this case, you don't need to even have the close proximity of the gear, right? You don't need to expose your persons in terms of the closed door in the same room as well. You can have someone sitting in their SCADA room and then monitoring this temperature. It's a great value, because the, I mean, again, go back to the slide where I mentioned, you go on the condition-based monitoring tools, your risk is extremely limited, okay? And then other things I'm looking at is a fixed IR camera, and also there's one more, there's the RFID tags. I mean, there are several techniques available in the marketplace, but you can go and evaluate. Everything comes with its own pros and cons. But the biggest point I would like to make on this slide is, nonetheless, what are the technology you are using? Just make sure that your employees are trained in using those, and then these things are documented, and they know how to interpret the data as the devices give it to you, okay? That's pretty important. So this is the next slide, thermography inspections temperature range, because most people ask, what is this reference point? This is taken out from ANSI meter standard 2019. So as you look at it, anywhere there's a temperature of 1 degree to 10 degrees C, that shows a possible deficiency warrants investigation, meaning you do this inspections, right? You do this continuous monitoring of the temperature, and then the system tells you there is a temperature within this delta. So what you do is, you just don't live with this, right? You need to go and make sure that you need to do additional investigation to make sure, understand what is going wrong. Is there any kind of a correlation between other parameters, or if the system is doing anything wrong functionality? You need to make sure that you go and thoroughly monitor and investigate the equipment to understand the underlying concern or the factor, okay? So if there is anything on a 21 to 40 degrees C, monitor until corrective measures can be accomplished, right? So and then the 40 degrees, major discrepancy, repair immediately. So you go and see something that's red hot or 40 degrees C, you just go and make sure that you perform this. So the one more point I would like to add to this is, not just the 1 to 10 degrees here, it looks pretty normal, right? So possible deficiency warrants investigation. If you look at one of the same standards, NFPA 70B refers to the insulation degradation over time and how it relates to the temperature, right? So 10 degrees C rise in the operation of the equipment, right? So though it doesn't require an immediate investigation or monitoring, but in retrospect, it's going to affect the overall longevity of the equipment. For example, if the equipment is designed for 30 years lifetime, right? And then you run this at 10 degrees C high. So what that's going to lead you to only 15 years. So your operation, your CapEx budget is going to put again 15, people to rebuy this equipment whenever they need to change this in 15 years or 30 years, this design operational life, okay? Threaded connections, Methods for verifying proper tightness of the initial, use the low resistance ohm meter to compare the connections terminals. And again, it's taken out from 70B. Verify the tightness of accessible connections terminations and calibrate the torque measurement tool. So not only you verify the torques on these connections, you also need to make sure that the torque tools are calibrated as well. And perform thermography, survey, or temperature monitoring systems on a regular basis, right? So, I mean, thermography programs, some people do like once in 6 months or once in a year. Just make sure whatever you're documenting the accurate data. And then second thing is you're comparing those things on a periodic basis, meaning you do this today and you do this like a year later, just go back and look at your previous measurements and check for the baselines and what is that variation it should be. But if you're using a temperature monitoring device, like condition-based technique, using any type of remote sensing tools, it's going to give you the trend over time automatically. So, along with that, there's a lot of technologies available, and we do a few of those as well, where you can take the temperature data and then combine that with any kind of the current measurements or voltage or frequency dips, and then make a determination how this data is relevant and what kind of corrective actions has to be taken to the defect, okay? So this is a slide for torque values for electrical connections. It's sample only. I mean, ANSI meter standards calls out like 6 tables on this. So make sure that you follow those, and this is just for reference purpose, okay? And then Article 225 talks about the fuses. The fuses shall be maintained and free of visible breaks and cracks. Fuse clips shall maintain the adequate contact with the fuses. And last but not least, you can't make any modifications. 70E clearly states that you can't make a modification to the fuse. Modify to allow the insertion into a current limiting one. You can't use a non-current limiting one and put it on a current limiting because it's a 2 different purposes, period, okay? So Article 225 and 225.3 talks about the insulated case and molded case circuit breakers. You need to make sure they're inspected, cleaned, verify there's a visual cracks or contamination, dust and debris. The contamination is one of the important things I would like to emphasize here, because in the industrial setting, you see a lot of this contaminants on this breakers, right? So which will lead to ventilation requirements, and which will in turn result in temperature rises. When the temperature rises, the contacts go bad or the equipment goes down, right? So just make sure that you monitor that breakers. Loose connections, excessive heat can cause a malfunction, nuisance tripping, and failure as well. And also whenever you're trying to look at the breakers, right? So breakers that interrupt the faults near the interrupt rating must be tested before you put it back in service. I mean, the reason they're calling is the breakers are not meant for like 5 faults, right? Whenever you use this breakers, they're not rated for the 5 faults to handle. They're just tested for 2, and they're designed to just handle only 1. So when the things are handling these faults at their max, to make sure that these devices are tested back to make sure the functional integrity is maintained, okay? System studies are all the important things. So electrical studies are integral to design, operation, maintenance. As I mentioned before on your even single line diagrams, you need to make sure the short circuit studies are done on a regular basis, coordination studies, load flow analysis, reliability studies, and also risk assessment studies as well. So load flow studies show basically the direction and the amount of power flowing from available sources to the load, and then the short circuit or fault currents represent a significant amount of energy that can be released to electrical systems. And make sure that you do the studies on a regular basis. There is a guideline here. I'm just looking at it. I think it's 5 years or so on this short circuit studies, if I'm recalling it right. And the reliability studies conducted based on the facility electrical systems to identify the equipment and associated risks, right? So as I mentioned before, risk assessment studies should also take into consideration the maintenance condition of, along with the equipment operational criteria, environment, and also the qualification of the persons handling those. Protective scheme maintenance, ensure the protection is operative, ensure the single lines are up to date, lubricate and clean the protective parts, and verify proper type and rating of the fuses. So you have to make sure that whenever you replace the fuses, you're going to replace that with the proper type and rating, so the functionality is not compromised, okay? So test and test methods determine whether any corrective maintenance or replacement necessary or desirable. So whenever you do any testing, you're just understanding whether there's any corrective action is required, right? So like a thermography program, or you're checking the tightness of the bolts and nuts, you need to make sure that what kind of a corrective action needs to be taken, not only just monitoring or testing those. To ascertain the ability of the element to continue the performance design function adequately. So to make sure your systems is designed or it's producing the same test values as what it's supposed to be giving out. So basically, ANSI NETA or NFPA 70E has definitive guidelines and the tables to that effect. So just go back and look at those. And that's available standards to buy as well from ANSI website. So to chart the gradual determination of equipment over its service life. So as I mentioned before, just as an example of thermography or high pot testing or insulation resistance or an electric strength, you need to go back and look at this previous records to make sure that these things, how do they compare and what kind of a trend it's showing you so that you can take the appropriate corrective action, okay? So life expectancy of electrical equipment, this is taken out from the sources of IEEE Goldberg, ABB, and CDA. So if you look at the transformers, they're designed for 25 to 30 years, circuit breakers are 15 to 20, switchboards and switchgear 30 to 40 years. The reason I'm trying to call here is the expected useful life is one, and the actual life is a secondary thing, right? So that actual life is going to be dependent purely on how you maintain the equipment that's been originally designed for. So that again brings back the question of how do you maintain this on a regular basis per manufacturer guidelines or the relevant standards in the industry, okay? So this is one of the charts because most of the times people ask the question, how often or frequent I need to do? This is a good guideline. I took a few snapshots from the ANSI META standards. This is the maintenance frequency matrix. You go and evaluate the equipment based on the criteria, the equipment condition. You know how your equipment is, right? So before you start your car, you know what's the condition of your car. The same way your equipment. So you can go and self-rate your equipment based on poor, average, or good, and then all the scores, right? And the reliability requirements, if you're looking at a medium or a high reliability, you take this 0.75 or 1 score, and then you go and take this and apply to the slides what I'm showing here. So there is a new installation or system modification. When you try to do the power system studies, these are the things that you need to do. 5 years, this is what I was talking to, 5 years since last update, incident energy analysis has to be performed. And there is like a lot of changes that's been brought into place with IEEE 1584 standards in 2018. Just go make sure that you verify that calculations, incident energy or flash calculations to your 1584 latest edition, and make sure you make those adjustments as required, okay? So these are the definitive visual and mechanical, electrical, all three different categories of different types of electrical equipment, right? So the ANSI META standards kind of define this in various buckets, like a switchgear, switchboard assemblies, or your low voltage, low energy. For example, let's look at the infrared, visual, electrical, and mechanical, right? It says 12 months here. So and then you go and check this based on your reliability requirements, on where you're looking at reliability needs of this, and then understand, evaluate the condition of the equipment as it says, and you apply that factor, and that's the frequency you should be using when you're performing this type of tests. Okay, this is a good reference chart. I mean, the NFPA, ANSI META standards is a 383 pages document. It's a wealth of information. You can just go and look back, and you can use the maintenance programs to be more effective, okay? So these are all, again, the different charts and tables that you can use that defines what those frequency of those maintenance tasks needs to be. And then you can adjust your programs accordingly. Okay. I think that's about all I have got for you guys. And we have another 10 more minutes as I'm saying the time. 7 minutes. I will take any questions. Please go ahead and use the questions pane here so that I can answer those questions. It's a lot of information. I mean, 70E gives the safety work practices, but 70B gives you the complete guidance on what those maintenance requirements are for. And that has like detailed information for every foreseeable component, as you can see with your electrical systems, like from your switchgear, MCCs, breakers, transformers, bus ducts, SCADA systems. Yeah, I mean, it's great information. You can just read that. Please, last slide again. Okay, here is the last slide. I mean, again, on the handout section, you guys have the complete presentation available for you to go and access this. Just make sure you go and take this. And also, as you exit the webinar, please take the survey, which will greatly help us in planning our future webinars. And also from Grace Engineered Products, we do have a hotspot monitor, which I talked about briefly, because this is not a product presentation. If you guys are really interested to learn more about it or understand how this product can help you guys solve this temperature anomaly defects at your electrical systems, please let us know with the exit survey. So our inside sales team or the applications team will reach out to you and help you see how it fits your needs. Okay. I'm kind of looking at the questions. Give me 1 second, guys. This is not as easy as I thought, especially this question span. Okay. For torque and maintenance should, okay, I need to look at one after all. Looking at the table 135C, NFPA 70E is essentially a checklist that you can use on most every job. If so, the likelihood occurrence would change from job to job, correct? Yes, that is correct. So you need to look at it based on the equipment basis. It's not like on your program level. Whenever you're doing this assessment, you need to make sure to use these tables in accordance with that specific piece of equipment, and then you evaluate that equipment condition based, and then you assess the risk accordingly. Yes. Yes, as I mentioned, the slides are there for you to download on the same webinar dashboard. You can download it. Please note that ANSI torque. Please note that ANSI torque spec for bolt sizes or for steel. That is correct. So I did not put all types of bolts and different configurations. So I just kind of gave you a sample. So this is no way a complete exhaustive list of everything. You need to go and look at ANSI Meta 2019 or an NFPA 70B to get the torque values across the board, so you can get what exactly you're looking for your equipment. What I presented on the slides is just like a snip to give you a feel for what exactly these tables look like. So we had a fire in our MCC wireway. Fire started on one way of the cable supplying power to a fan with a 40 HP motor. Believing fire started at butt plies connector, no protection, jump, breaker, thermal overload, fan cable installed 1991. Yeah, this is one of the things that's a classic situations where you have this temperature anomalies that gets unnoticed and that could lead to kind of a fire, right? So the consequences are pretty significant as a result of this. Does GRACE PESDs need periodic calibration? This again, the PESDs is not the discussion for this topic here. The GRACE PESDs are self-calibrated. There is no calibration required for the PESDs or any of the products what we do. Everything is factory calibrated and there is no calibration necessary. So if the device is not functioning, you will know that indication from the device itself that will tell you it is time for you to replace it. Okay. What is the ANSI codebook again? So ANSI codebook is ANSI Meter 2019. That is the standards. I can send you guys what is that exact publication number as well. If whoever has attended the webinar will get the continuous education credits. I think our marketing team will follow up and they will send you the CEU certificate for the attendance. Yes. How are all this PM program fit into IIoT since most of them are still time-based? That's a very great question because I think the PM programs cannot directly tie into your IIoT as it sits. All you can do is basically take this documentation or the data that's been archived from years, and you can take that information to your cloud. And in the future, whatever you are monitoring the IoT-based devices using wireless technologies, you can compare the data with the data analysis. But these things don't talk to each other. You can take the previous information on historians and you can compare the data to what the new devices are monitoring at a current level, but you can't go back and get the trend over data, time over data trending from the past because you never had, right? So, and I think most of the devices on electrical equipment as they're designed today are coming up with some level of sensors and systems in place. Digital switchgear, they call it, like Siemens, ABBs, Eaton's, all the big manufacturers have this digital switchgear. You can go and look at their website. So probably they have the ability for you guys to go and integrate the data from the archival system. So how does a normal operation affect operator or a maintenance staff PPE requirements? So, I mean, the normal operation, when think about, I mean, I'm not going to dwell into this specific thing in detail, but I'm going to give a simple analogy, right? If the doors are closed and if you're performing a task, that's more like taking a measurement on a meter, that's normal operation. If you meet all the conditions of 6 conditions that's been outlined in NFPA 70E, right? And then if you're opening the cabinet and performing a task in energized condition, that's a totally different task. That's what I would like to create the difference. And the PPE rules apply per your facility guidelines. So if your facility requires an arc flash category or arc flash category 40 cal PPE to be worn in, when you are entering electrical rule, you need to follow that because that's not defined by me or the OSHA. That's your facility's procedures. However, if your procedure calls for arc rated, you can use that too because what is normal is very subjective term, right? So from an electrical standpoint, a work can perform energized fashion when the doors are open is not a normal operation. That's energized work. So you need to don with the PPE what's appropriate for that arc flash category, okay? And if it is work that's being performed outside the cabinet, and when you meet all the 6 conditions of that NFPA 70E, then it is a normal operation. And whatever is construed or defined as normal PPE, normal operation PPE by your facility, you need to follow that, okay? Hope that answers the question. Where did you get the maintenance? Maintenance frequency matrix came from ANSI Meter Standards 2019 edition. I will send you all what's the reference standards that's been used in the PowerPoint so that you have a reference to what I talked in this presentation, okay? I think we're past the time. Any other questions, guys? I mean, please take the webinar survey, and also my email is there. on the last slide, which was supposed to be. So my email is on the screen. Plus, please do send me an email if you have any additional questions. We'd love to answer those. Yeah, please do take the survey as you exit the poll and exit the webinar. Okay. Thank you so much, and stay safe, guys. Have a great day and stay safe. Thank you.